participants. I gladly welcome today's chief guest, Dr.S. Kannimuthu sir, Professor, CSC, Karpagam College of Engineering, Coimbatore. I welcome you, sir, on behalf of SNS College of Technology, Department of Information Technology.
Thank you, ma'am.
Now I request Dr. C. Sendil Kumar sir to introduce our chief guest.
Good morning to one and all. Dr. Kannimuthu Subramaniam, working as a professor in the Department of IT, Karpagam College of Engineering, Coimbatore, and he had a experience of 14 years of teaching and 6 months of an industrial experience. His areas of interest are machine learning, data structures and algorithm, big data analytics, artificial intelligence, and he had received more awards from for various achievements. He had successfully completed more than 600 plus online certification courses in Coursera.
Sendil sir. Sendil sir.
Administrative regions, and he had published more than 45 journals, journal publication in his various national and international journals, and he had participated and presented papers in more than 9 conferences of various top level institutes, and he had organized more than 11 plus seminars and workshops at various top level institutions. So I kindly welcome Kannappan sir for having an interactive session for today's FDP. Kannimuthu sir. Sir, good morning, sir.
Good morning, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you, Sendil sir. Now
Thank
I
you,
request our chief guest, Dr. Kannimuthu sir, to take over the session.
Yes, ma'am. Thank you, ma'am. Are you able to view the screen, ma'am?
Yes, sir.
Yes, ma'am. Thank you.
Yes, sir.
Thank you. Good morning, honorable presenter here through online. This is Dr.S.Kannimuthu from Karpagam Institutions. Today, I wish to present session on open source web framework for virtual reality, for developing virtual reality applications. Before getting into the session, I should thank the management of SNS institutions, ATAL ATP officials, Dean CSC and IT, Nithya ma'am, for providing this wonderful opportunity for presenting the session in virtual reality. Today's agenda is to discuss about virtual reality, that is introduction to virtual reality. Then I will tell about types of virtual reality, then architectural components which is pertaining to virtual reality. Then I will discuss more about virtual reality web framework for developing the virtual reality applications. Then I discuss about A-Frame, that is one of the web framework for developing the virtual reality applications for several applications. Finally, I end up with demonstrations. So before getting into open source web framework, I wish to review the virtual reality applications. The previous session, you came across the basics of virtual reality. Actually, virtual reality is the illusion of a 3D interactive computer-generated reality where sight, sound, and other aspects are simulated to create pictures, sounds, and objects that actually seem real. We can do animations with the help of a virtual reality environment. Concepts which is related to virtual reality. Okay, it's awesome actually. Virtual reality must allow the user to view the environment from any point at any angle. There is a beauty of virtual reality, and virtual reality must allow the user to interact with the objects in the environment. Okay, we can easily interact with the environment, and also we feel the realistics of the environment if we use visual reality applications. So I start with the history actually. The virtual reality systems are invented from 1956. Sensorama, it is considered to be one of the earliest visual reality systems. And during 1968, the first virtual reality head-mounted display, that is the Sword of Damocles, was created. During 1977, one of the movie map enabled users to take virtual tour of Aspen, Colorado, okay, which is developed by MIT. During 1984, Jaran founded VPL Research, that is one of the first companies to develop and sell virtual reality related products. During 1991, the first virtual reality arcade machine, that is virtuality, was introduced. During 1994, Sega introduced VR1 motion simulator in its Sega World Arcades. During 2007, Google introduced Street View, which provides panoramic views of locations. During 2010, the first prototype of the Oculus Rift headset was designed. Okay, that is a major invention. During 2014, Facebook acquired the Oculus for $2 billion. Next, in 2014, Sony announced the launch of Project Morpheus, a VR headset for its PS4 console. During 2015, Apple awarded the patent for a head-mounted display apparatus. During 2015, Google launched a Google Cardboard, which uses a head mount to turn a smartphone into a VR device. Now we are using several smartphones which can enable us virtual reality applications. Okay. So during 2015, Samsung launched the Gear VR headset. At the same year, HTC Vive headset developed by HTC and Valve was unveiled at Mobile World Congress. During 2016, the first generation Oculus Rift device was released. During 2016, Sony introduced PlayStation VR. During 2017, Microsoft launched the Xbox One X, its VR-ready games console and headset. During 2018, Facebook revealed camera loader glasses, which is optimized for social virtual reality. During 2017, the same year, Facebook released untethered Oculus Go headset. The same year, Lenovo introduced the headset running Google Daydream that became available. During 2019, Sony announced that it had sold more than 4 million PSVR headsets. During 2000, this year, more than 85 million VR headsets will be used in China, according to the PwC. So in future, 2023, cloud-based VR gaming will be increasing prominent, supported by 5G as well as 6G network. At 2030, VR will be $28 billion market, according to the global data forecast. So these history are retrieved from virtual reality thematic research. Okay, it has large scope and we have open problems to solve. Okay, the virtual realities are used in several applications, especially medical applications. So I used to discuss about types of virtual reality. This is something like a review. I already came across these things, I think so. So first type is immersive virtual reality. The use of special purpose equipment, okay, that is involved in immersive virtual reality. You realize the feel of presence if you use immersive virtual reality. The immersion, that is immersion into a virtual reality, is a perception of being physically present in a non-physical world. Okay, that is a feel of presence. The perception is created by the surrounding the user of a virtual system in images, sound, or other stimuli that provide engrossing total memory. Okay, when you touch a particular object, you may feel the presence of a real world actually, okay. But that is not a real world; that is a non-physical world. And another type is window on the world. It is also known as text of virtual reality. We use a monitor to display the visual world, and it does not require a special hardware. Okay, it is very low cost and low performance, and it is less immersive. You may not realize the feel of presence. Okay, if you use window on the world. The other type is telepresence. Okay, in telepresence, the interactions are reflected to some real world object. Okay, so for example, the interactions may be recorded. The after satisfaction is applied to the real world object. Okay, so you may record the interactions with the help of human interventions. After that, if you are satisfied with the interactions, you can apply to the real world object. Next type is augmented virtual reality. Actually, the computer generated inputs are merged with the user's view of the world. The augmented reality adds digital elements to a live view, often by using the camera on the smartphone. Okay. So there are many mobile phone applications making use of augmented reality. So these are the types of virtual reality that you came across. Now, just to tell about architecture of virtual reality system. So virtual reality system has main components like input processor, simulation processor, rendering process, and we have a world database. So I explain one by one. So I start with the input processor. Actually, input processor is accept the input from the position in terms of position and orientation actually. So the device is used to input the information to the computer. It is called input processor. The object is to get coordinate data. We may input coordinate data to the rest of the system with minimal lag time. So some of the input devices are keyboard, mouse, through keyboard, mouse, 3D position trackers, and voice recognition system, etc. Next component is simulation processor, which is a core of a virtual reality system. Actually, it takes the user inputs along with any task programmed into the world and determine the actions that will take place in the virtual world. Next one is the rendering processor. Actually, the rendering process is used to create the sensations that are output to the user. Each separate rendering process are used for visual, auditory, haptic, and other sensory system. Each renderer takes a description about the world. There is a ended description about the world state from the simulation process, or derived directly from the world database for each time step. The next component is which world database. Okay, it stores the objects that inhabit the world. That is, it contains the script that describes the actions of those objects. So now I wish to discuss about the web framework, which is a very important topic in this session. Using VR equipment, virtual reality equipment, we can manipulate the web pages. There is a cool experience staying in an immersive website. Actually, web virtual reality is a experimental JavaScript API, okay, which is a library that yields support for virtual reality devices such as the HTC Vive, Oculus Rift, or Google Carpagam in a web browser. Okay. You don't need to install any software, additional software for working with the virtual reality environment. Okay. So it is a JavaScript-based applications actually. There are 5 important web virtual reality framework you came across. Okay, first one is A-frame. Okay, that is a very important web framework for developing the virtual reality applications that I will discuss later. And the other web frameworks are WebVR, Primrose, React VR, Organ.js. These web frameworks make use of JavaScript for developing the virtual reality-based applications. So I start with discussing about A-frame. Actually, Mozilla VR team created a A-frame to kickstart the web VR ecosystem. Actually, it offers web developers the power to build the 3-dimensional and virtual reality worlds. Actually, A-frames handles the 3D and the WebVR, which is very simple. If you know the fundamentals of HTML and JavaScript, means we can easily develop the virtual reality-based applications, and also we can do animations. Okay, we can do texture mapping and other other operations with the help of web frameworks. So since A-frame can be used from HTML, okay, that leads to the frame that is accessible to everyone. It has cross-platform and superior performance. Okay, we can found the source code, that is source code, and libraries from the GitHub web pages. The official documentation is available in the aframe.io website. And the other web framework is WebVR. It's an open standard that makes it possible to experience virtual reality application in your browser actually. And the goal is to make it easier for everyone to get VR experiences, no matter what devices you have. Okay, it's cross-platform application. The source is available in GitHub actually. Official entry is available in the webvr.info. That is the second web framework. But I will discuss about A-frame web framework, which is very famous for developing virtual reality-based applications. Next web framework is Primrose. Is an immersive environment for web browsers on desktop and mobile devices. Within this environment, developers can be an application that progressively enhanced to support users in a wide variety of form factors, including higher-end VR itself. Okay, we can develop applications and which is related to animations and other any other applications. We can even design game applications with the help of Primrose. Using Primrose, we can make web application that is straightforward. The basic concept is to create an environment that wraps around a standard 3D JS scene. JS is a JavaScript file, which provides the environment for creating the 3D objects, okay, and animations. This environment actually handles the basic interactions of a scene, such as common user interface for entering the VR mode and progressively enhancing the between desktop, mobile, Google Carpagam, and other hardware devices, which is related to virtual reality applications. The official entry is available in GitHub. I mean, the sources is available in the GitHub, and the official entry is primrosevr.com. Next, React virtual reality. So React VR lets you build VR apps using only JavaScript. Okay, by using React.js, we can implement the application. It uses the same design as React, letting you compose a rich VR world and UI from different components. So this is the source code link. Okay, GitHub link, and the official entry is available in facebook.github.io. Next web framework is Organ.js. It is an open standard augmented reality platform for the web. Initially, it is created to support AR applications, AR-based web applications for Organ for browser. Actually, Organ.js is now aimed at supporting the augmented reality in any web browser using whatever capabilities are available on each platform. So this is the GitHub, so there is a link for downloading the source, and official entry link is organ.js.io. Okay. Actually, web framework, okay, the combinations of WebVR and WebGL APIs are available in the web framework actually. The WebVR and WebGL APIs already enable us to start creating virtual reality experiences inside the browsers. But actually, the community is still waiting for tools and libraries to appear to make this easier. Okay. So initially, it was very tough. Now we have several libraries, open source libraries, to support development of virtual reality-based applications. Actually, Mozilla's A-frame framework provides a markup language, specialized markup language. Okay, it allows us to build a 3D virtual reality landscapes using the system familiar to web developers, which follows HEM development coding principles. So this is looking like a HTML script only, markup only. Actually, the web framework is useful for quickly and successfully building prototypes and demos without having to write a lot of JavaScript or GLS here. So in earlier days, we have used OpenGL and GLSL applications for developing the virtual reality-based applications. Nowadays, we are using web frameworks for developing the virtual reality applications, which is open source, openly available, and cross-platform. Actually, A-frame is built on top of WebGL, okay, that I used to discuss in depth. And it provides pre-built components to use in applications like models, video players, skyboxes, geometries, controls, animations, cursors, etc. Actually, it is based on the entity component system, which is known in the game development world. But it targets web developers with a familiar markup structures and manipulable with JavaScript. The end result is 3D web experiences which are VR enabled by default. Okay. So for running the applications, that is A-frame based virtual reality application, it is better to use Mozilla Firefox. Sometimes not all the applications executed in Google Chrome. You can use Mozilla Firefox for running the applications, A-frame based applications. So it runs on desktop, mobile, that is iOS or Android platform, and also it is executable in Oculus Rift, Gear VR, and HTC systems, hardware systems. So this is the simple HTML structures, which can be executed online, okay, by using Klitsch tool, that you can refer from internet. Just make a note, Klitsch tool. By using this tool, we can execute the virtual reality-based application through online, okay, without installing the software, any software. Or even we can work with desktop system to create virtual reality-based application. This is the general structure of A-frame application. You just have a HTML file, header sections. Okay. Inside the script, you have to mention the source. Okay. You have to download the library API called aframe.min.js. Okay. So that is downloaded. Then we can work with A-frame applications. The first step is to create an HTML document inside your project directory and create a index.html file and save the that is a application by using .html. Okay, and we can place the A-frame script inside the body sections. So first I will start with how to initialize the scene. Actually, scene is the place where everything happens. Okay, when creating a new object, okay, in a virtual reality environment, we will be adding them to all the scene to make them visible on the screen. In A-frame, the scene is represented by a scene entity. Okay, entity is something like there is a tag. Okay, we have a hyphen scene tag to create an environment, virtual reality environment. So let's create the scene by adding a hyphen scene tag. It is a beginning tag. We also have end tag for this. Okay, it is this scene is placed inside the body element of the HTML script. So by using a hyphen scene tag, we can create a or initialize a scene. Actually, a scene handles all of the setup that is required for creating the 3D environment, setting up the web graphic library environment. We can set the canvas, camera, lights, renderer, rendering loop, as well as out of the box web VR support on platforms such as HTC Vive, Oculus Rift, Samsung Gear VR, and smartphones like Google Cargo. So all the setup is happening if you set the keyboard that is tag called A-C. Okay. So A-C alone take a lot of load of us. Okay. You don't bother about how to create a environment for creating 3D canvas, how to set up a camera, lights, render, etc. Everything is handled by A-C tag. So now I have created an object in a 3D environment, okay, virtual reality environment. Now I wish to transforming a entity. Entity means any object, any 3D object, a 2D object, which is drawn in the virtual reality environment. Okay. Before getting into there is other tags, I need to tell how to transform an entity into in 3D. It follows some rule actually. The A-frame web framework follows some rule. Let's first go over 3D space. A-frame uses the right-handed coordinate system, which is depicted here, with the default camera direction, positive x-axis, and extends to the right edge. First x-axis extends to the right, and positive y-axis extends up, and the positive z-axis extends out of the screens towards us, towards you. Okay, that is the concept that is following while transforming entity in 3D. Okay. A-frame distance unit in meters is represented in meters because the WebVR API returns host data in meters. So we represent the information in meters only. When designing a scene for virtual reality, it is necessary to consider the real world scale of the entities we create. Okay. For example, a box with height equal to 10 may look normal on your computer screen. Okay. But in VR, the box will appear massive. Okay. So it is better to give small value while specifying the measurements. Okay. That is in script term, just to mention small value for an attribute that is corresponding to the tag. Actually, A-frame's rotational unit in A-frame is in degrees only. Okay, although it will get internally converted into radians, we are representing the rotational unit in degrees. Okay. For example, you may have a necessity to rotate the object, 2D object, maybe circle or sphere, in particular angle. So for those, we are representing you are giving the input in terms of degrees, but internally it is converted into radians. To determine the positive direction of rotations, we use a right hand rule. Okay, right hand rule means you just point our thumbs down the direction of a positive axis. Just point our thumbs down the direction of a positive x-axis, and the direction which our fingers curl around the positive direction of rotations. Okay, that will be discussed later actually. Okay. So the direction which our fingers curl around the positive direction of the rotations. So before getting into this transforming an entity, in depth, I wish to tell about the fundamentals of geometry. So we can draw the geometrical objects, and also we can do animations with the help of form. There is mathematical computations. Okay. First, I wish to tell about rotation transform, followed by scale transform, then parent children objects. Okay. So rotation transform, a 3D object is made out of 3 basic elements, okay, particularly vertices, edges, and faces. Actually, a vertex is a point in space that you know already. A vertex has coordinates like, if it is 2D means x, we have coordinates like x and y. But we are here now, we are dealing with the 3D object. So we have 3 coordinates, x, y, and z coordinates. Connecting 2 vertices create an edge actually. If you connect 3 or more vertices in a loop, you have created a space. I will give a diametric representation. This is the example for vertex. Okay. Simple point representation is called vertex. Okay. By using 2 vertices, we can create an edge. By using more than 2 edges, we can create a face. Something like a shape, which may be 3D shape or 3D shape. So in 3D modeling, every object in a scene that has a transform. Okay. It is used to manipulate the position of an object, rotation of the object. Okay. We can rotate by an angle, or we can scale up or scale down the object. Okay. So that can be performed with the help of transformation. Okay. So you can transform these properties for x, y, and z axis, and the default value for position, rotation, scale is given here. Okay. Position is 0, 0, 0 for every coordinates. Rotation is 0, 0, 0. These are the initial values. Scale is 1, 1, 1. Okay. When you give 1.5 for 1.5 for scale means the size of an object is scaled up by 150%. Initially it was 100%, it will be scaled up 150%. And we can rotate the object by an angle, by x-axis, by using x coordinate, by in terms of y coordinate, in terms of z coordinate. That can be done. Okay. So again, I wish to tell about thumb rule. There is since A-frame is a right-handed coordinate system, the rotation value can be defined by the direction your right hand curl into when your thumb is pointing at the positive direction of the extrusion axis. This is the positive direction of extrusion axis. Okay. And in this example, the thumb is pointing at the positive y-axis. Here we have positive y-axis, that is vertical. Your thumb is pointing towards y direction. And thus the direction of positive y-axis indicated by a from this. And the rotation, the positive rotation happen in anti-clockwise. Okay. So that is represented in terms of arrow. There is a pink, there is violet color arrow. Okay. That is a positive rotation. And if you go in the opposite direction, that is called negative rotations. So here, to rotate the particular object in a there is a virtual reality environment, we can use a rotation attribute. For example, I am going to create a box, okay, 3D box, maybe 3D cube. Okay, so we can rotate it by using rotation attribute. Okay, so a box is a tag, okay, it's an inbuilt tag, which is available in A-frame library, JavaScript library. By using a box tag, we can create a object called a 3D object, something like a cube, and you can set the positions, rotations, and colors. Colors may be represented in terms of hexadecimal value. Or you can use color name itself. That is possible. Here I have mentioned position in terms of x-axis, y-axis, and z-axis, coordinates, just something like the coordinates, and the rotation in terms of y-axis. That is with respect to y-axis, rotation with respect to y-axis. That is why I have mentioned non-zero value in the second coordinate system. This A box, there is object is created inside the scene only. If it is not If it is not mentioned inside the scene means it will not be displayed on the virtual reality environment. So this is the positive y-axis rotations. Okay. So this is an object, 3D object that you have created by using block. So if you use rotation equal to 0, 45, 0 means that will be handled with the positive rotations. When you mention minus 45 means it will be happen in opposite direction, negative. Next one is scale transform. By setting the scale value, an object gets multiplied by the value to increase and decrease its size. For example, setting a scale value of 2 will double the size of an object. Initially it was 1. If you give a scale value as 2 means, it will double the size. When you give 0.5 means, it will divide the size by 2. Okay. So you can use floating point value for mentioning the scale. Okay. This applies to each axis separately. Okay. You can give for x-axis, y-axis as well as z-axis. For example, the x scale value of 1.5 stretches the object to 150 of its original width. Okay. This is a z scale value of 1. When you give 2 means it will extend double. It will just double the size. Okay. The y scale value of 0.5 halves the height of the object. When you give 0.5 means it just halves the height of the object. Okay. So actually, x represents height, y represents width, and x represents width, y represents height, and z represents depth. The scale transform can be applied by adding scale attribute. Okay. So every 3D object has scale attribute. Here we need to mention the values. That is, you are scaling with respect to x-axis or y-axis and z-axis. That is mentioned. Here I have mentioned here by default 100% data. I mean, actual size of the data is represented here. If you wish to scale the object, we can mention 2 represents double the object, 1 represents same size, 0.5 represents decrease the size by 2. Okay. Decrease size by half. So this is the example for scale transform. I also told about rotation transform. So this example for scale transform. Next, another transformation in 3D object is parent of children object. There is also an additional option in transform which to parent an object to another. Okay, we can associate one object to another object. The changes that is happening in the particular object may be reflected in the child object. Okay, so when an object is a parent of another object, changing the parent's transform will affect the child's transform as well. If you do scaling or rotation, the changes will affect it. Okay. To show the example, we create a entity in order to make paradigm. So if you wish to associate one object with another object, means we can use entity tag. Okay, that is represented here. Inside the entity tag, we can create more than one virtual object, that is a 3D object, and which has association between each other. If you make change in any object, that will be reflected in another object. It is mentioned in the entity. Inside the entity, inside the scene, you have to have an entity tag. And inside the entity tag, you can create a 3D object. An entity is just like an empty state of an object. It does not have any geometry actually. Yet you can transform values. You can store the transform values. To make an entity store an object, this just simply create a object before closing a slash entity. So inside the entity, just have an object and close with the entity tag. This is an example for parent child object. Inside the entity, I have the box, that is 3D object, something like a cube, and I can set this position of an entity. Okay. Whatever position that is, which is considered a relative position actually. Here I have mentioned -2, 0, -1. This is the starting point of this object. Okay. So we can, if you change the position in the A box means The changes made in this A-box is, changes made in the NDT is reflected in the A-box itself. Okay. And also we can keep other objects, okay, other objects like the circle, torus, cube, cone. Other objects also we can place inside the NDT. Okay. So I used to tell about other objects. Okay. And now I have mentioned only box. Okay. So this is the output. Okay. Output for the particular example. Now, if I wish to create a cube means you can use A-box as I said already. Okay, you can set the color, you can set the position, and you can set the rotations. Okay, so this A-box tag is placed inside the scene tag. It contains parameters that is already defined. We told about this. Example, to translate, rotate and scale the box, we can change the position, rotation and scale components. Okay. So here I have set the color for a box as red, rotation angle with respect to y-axis and z-axis 45 degree, and I have scale up, which is used to double the size of the object. If I wish to set the background for a 3D world, means we can do that by using skybox. A skybox is a background for the 3D world. It is represented by a-sky element. In our case, we will use a simple color, and also we can make image as a background. Okay. So looking around the world, an impression of being inside an open sky, okay, wooden band, wherever you like it. So whatever one background want, you can do that. Okay. Otherwise, you can create a 3D object which will be considered a background. So by using a-sky tag, we can do that. Okay, here I have set the background color. Okay, for the 3D environment, visual reality environment by using sky. Next one is demonstration. I will create a 3D objects in a visual reality environment. I will work with that. So I have a example applications. You saw the demo. Just a minute, participants. I will show the demonstration. Are you able to view the output, participants? Yes, participants. Please tell me, are you able to view the screen? Uday sir, are you able to view the screen, sir? So by using this virtual reality mode, you can. In lower right corner we have a VR mode option. Just click that. Okay. So we can view the virtual reality environment. So by using mouse we can move the object, 3D object. I think you are able to view the screen. And also we can make it big by using keyboard arrow, up arrow and down arrow. This is the way of creating the object. I will explain how to do that. So initially when you open the browser, the object will be looking like this. When you click VR mode, it will be entered into the virtual reality. I'm just clicking this, and we can move the object in different angle, and also we can string up and string down using the arrows. Okay. The keyboard control also will be provided. This is the example applications, virtual application. We can. I will show the code for this. Simple code only. We can create a object, different kind of objects. I think you are able to view the script for creating the 3D object. First of all, we need to create a HTML tag. Inside the HTML tag, you just have a head tag. This head tag, we just mention the script as a HTML script. You just get a library from library. There is a web. Okay. If you download the A-frame min.js API in our system means, okay, just keep the JavaScript file in a particular directory and place the HTML file in the same directory. Okay. Otherwise, get a library from URL. Okay. Just mention the source. Inside the body tag, just to create a scene. This is the parent of parent node or parent tag for creating the virtual reality environment. And I have created the different objects like cube, sphere, cylinder, and a plane. Okay. So the attributes, that is positions, rotations, colors are represented. Okay, for every object. Okay. Box tag is used to create a cube. Sphere tag is used to create a 3D object. Okay. And the cylinder, we can also create a cylinder based in cylinder tag. We can create 3D plan by using A-plan tag. And you can, for setting the background image, we just use A-sky tag. I hope you understood. Okay, I told each and every attribute I discussed in the presentation. I'll go to presentation. So before getting into this other geometric object, I have to tell about how to specify a camera. I already told that while giving the tag itself, that is scene tag itself, the camera setup, lights, everything is happening. Okay, virtual entertainment also will be enabled. So here we have a camera entity that can be created by adding an A-camera. Okay, we can set the position of the camera, okay, default position of the camera explicitly, and move it back to a little bit from the center of the scenes. So we'll be able to see these shapes. Okay, so we can add this by before closing the A-C, like skybox that you mentioned earlier, like this just mentioned by specifying the camera. So the A-camera is used, which contains several attributes: position of the camera, and you can set whether cursor need to be visible while viewing the 3D object, and you can scale the cursor. You can change the color of the cursor and opacity of the that is camera. Next, if you wish to add the light to the 3D environment, means we just use A-light tag. So A-light tag contains type, color, intensity, positions. Here we have two types of lights, that is direction light and ambient light. So the direct light, by default, direction light has white color. Its intensity is set to 0.5, and it is placed at position -1, 1, 2, according to this script. The ambient light only needs a color, which is also a white. Okay. So we can set a color to the particular virtual reality environment. I told about these tags in demo. This is the markup already to explain about this. Next concept is animations. Animations are the key part of all 3D creatures. They attract our eye and bring his scene to the life. So in medical application also, we can create a animations for showing the anatomy of a particular object. So we can easily create an animations in A-frame, placing the A-animation element into the scene tag. Okay. We can then decide which properties we want to animate. With this in mind, we can make our entity move the way we want, modifying the attribute like position. We can rotate it, change the position. We can change the rotations, and we can scale up or down the object, and we can change the color. Okay, while doing the animations. We can have a scene with a box entity. Okay, attaching the animation as a child of your box will label the attribute as positions. Okay. So if you wish to associate one object with another object, means we can use entity tag. So animation has 4 major attributes. One is duration, then from, to, and repeat. Duration is represented in terms of milliseconds of the animation. The higher the value, the slower it will move. From tag is from attribute is used to set where the animation starts, and the to attributes is used to set where the animation ends. And we can use a repeat attribute, okay, which indicates how many times you want your animation to repeat. If it is indefinite, so it will go on forever. So before getting the animation, I will tell other object, 3D objects. We have A-text tag, which is used to display the text on the 3D board. Okay. Which has several attributes like align, color, height, width, value, okay, which is something like a HTML attribute. And we have circle attribute used to create a circle. Okay, A-circle is used, which has a beginning tag and end tag. If you mention a circle attribute, just to mention the radius. I have a circle attribute. You can represent the color and as well as the radius. And also we can give a image, okay, for a particular attribute. Here I have a circle. I used to draw a circle which is wrapped with the image. Okay. For the purpose, I just create an asset by using an asset tag. Just load a image and create an ID for an image. By using this ID, we can wrap the circle. Just after drawing the circle, just create a circle and image that is mapped with the circle. In that, we can mention the radius of the image, radius of the circle as well as the rotations. Okay. The texture mapping is done. We can wrap the image or video over the particular object, 2D object or 3D object. Okay. It is called texture mapping. That can be performed. We can create a ring by using ring tag. A ring primitive creates a ring and disk set. So, which has several attributes like color, inner radius for a ring and outer radius. So we can wrap the image with the ring by using the image tag. So here just mention SRC tag, SRC attribute. Inside the attribute, just mention the file name. So if you mention the file name, automatically the image is wrapped over the ring. Okay. Next, A-frame tag is used to create a flat surfaces. Okay. So we have attributes like color, height, width, and also we can wrap the image inside the plan, above the plan by the help of source attribute, and also mention the height with the rotations. We have a cone tag, A-cone tag to create a cone. Can create a cone set. Here we need to mention the source. If you wrap the image with the cone, you can mention the bottom radius and top radius by using the radius icon bottom and radius icon top. And also we can create a triangle shape, okay, by using A-triangle. So we need to mention the coordinates. That is A coordinate for A, coordinate for B point, and coordinate for C point. Okay, inside the triangle, and also we can mention the color. You can also draw one of the three-dimensional shape called torus. Okay, you need to maintain the dimension, the arc in terms of angle, color. You can mention the radius and tubular radius. Okay, for torus we need to have a tubular radius. You can create a sphere by specifying the radius and color. Okay, you can animate the sphere. And there is another important attribute is curved image. The curved image primitive creates an image that bent around the user. Okay. Curved images arranged around the camera can be pleasing or legibly since each pixel sits at the same distance from the user. They can be a good size than angled flat plans for complex layouts because they can ensure smooth surface. The curved image ensures smooth surface, okay, rather than the series of awkward seams between planes. So we can create a plan and we can wrap the image over the plan. That is happen, but we can't feel good. We may not be able to feel better feeling if you draw the image over the plan. If you use curved image, means you get a better feeling. Okay, that is why we have introduced a curved image tag. Okay. Which has several attributes like source, height, radius, theta length, rotation, scale. So these are the attributes. So rotation is a common rotation, scale, and position attributes are common. Next, video attribute plays a vital role. Okay, we can create a texture on a flat plan. Okay, inside the virtual reality environment, we can create a plan. Inside the plan, we can play a video. Okay, we can play a video in 3D surface also. That is happening by using A-video. So we can mention the source of the video and with the height of a particular object where you should play the object that is mentioned here. And also we can play the video in a 3D object by using video sphere. The video sphere primarily plays a 360 videos in the background of the scene. Video spheres are a large sphere that video takes a map to the inside. Okay, I will show the demo for video sphere. So it will sound interesting. Then you are able to view the browser, Mozilla browser. Enter into virtual. They are viewing the video. So we can move the object. We can move the image, that is video. We can zoom the video, that is happening. We can zoom the video. Okay. We can zoom out the video, that is happening. Okay. In the 3D virtual environment, we can place the video and we can move. We can stretch. We can stretch or string by using the mouse control. It also has default keyboard control. Okay. So, very interesting. Okay, we use a script. No need to install the software and all. Okay, for creating the virtual reality environment. If you use A-frame. Okay. And also give rotating the box. And also I just use another demo. Flow. Okay, this is an example for texture mapping to map the image over the globe. See here, I have an image actually. I have loaded the image and mapped over the sphere. That is why it is looking like this. Okay. Actually, I did a project in PG, okay, which makes it open GL. Okay. That is very tough actually. To perform a texture mapping itself, I need to write 1,000 lines of code. But now, by using 5 lines of code, I can do this texture mapping, and also I can create virtual reality experience. I can shrink the object. I can zoom out the object. Okay. So if the pixel value is high, means you will create an accurate picture of the image. Okay. So you have keyboard control and we have mouse control. So see here, I use mouse to explore the map. Okay. So it is mainly used in weather forecast, and also we can develop the application for medical application. This we can identify, we can represent the human anatomy and we get to know about each and every parts of the body. Okay. And also we can give a image, okay, particular image for the MRI image or some other image. You can get just use a mapping, texture mapping, and by using one step, you just apply the image over the shape and you get a real feeling, okay, of a human body and human body parts. Okay, so it will be very useful in virtual reality applications. So mainly we use that is virtual reality applications in medical domain for getting know about this human anatomy, and we can identify the disease and the severity of the disease by using visual data environment. For example, we can detect the disease, whether the particular person is having the autism disease or not, and the severity of the disease by creating the visual reality environment, okay, in a medical field. So this is the example for texture mapping and animation. I hope you got this experience. Next I will explain other. Do you have any doubt, participants? Please let me know. We will raise. Do you have any doubt, participants?
Professors, if you have any questions, you can post it now. Professors, if you have any doubt, you can also post it in the chat box. Else we can wind up the session.
Professor, good morning, Professor. I'm Gautam from Jansen's, Professor.
Yes, sir.
Professor, recently in many ads in YouTube or ads, they will be showing that AI device now, Professor.
Yes, yes.
They will be wearing a head and they will be watching like gaming applications. In future, how it will be? It will be applicable for mobile also, Professor.
Yes, sir. Yes, sir. It will be applicable for mobile. Whatever applications developed by using desktop is also applicable for mobile applications, sir. Mostly it is AI enabled.
So what is the difference between while we are using in mobile as well as using in VR and that particular device, Professor? It will be in 3D view or?
Yeah, it may be in 3D view, sir. Like if you are using head-mounted display, you feel the presence, 3D presence.
Okay. So, last question: what will be the cost of that? Whether it's available in the market?
It is available in the market, sir. Google Cardboard is available in the market, sir. It starts from thousands actually.
Oh, start from 1,000. Okay.
Sir.
Okay, sir. Thank you.
It is based on the quality, sir. Quality of the is openly available. We can buy it from Amazon website, sir.
For example, school students, they are using the lens-like device, sir. It will be enhanced from the mobile and it will be enlarged. Okay.
Yes. Similar way we can use.
Thank you, Professor.
Yes, sir. Thank you.
Professors, any other questions? Professors, we are winding up the session. If you have any questions, please post it in the chat box or please post it in the WhatsApp group. And as we are running out of time, we are closing the session. And on behalf of IT department and SNS College of Technology, we thank you, Mr. Kannimuthu, Dr. Kannimuthu, sir. Thank you for your valuable advice and valuable knowledge sharing.
Yes, sir.
Thanks a lot, sir.
Thank you, sir.
It's an immense pleasure to have you here in the session, sir. Thank you. Thanks once again, sir.
Yes, sir. Thanks a lot for providing the opportunity.
Thank you, sir. Thank you. Participants, thank you for your presence. We are wrapping up the session, session 1 now, and we are starting the session 2 by 11:45 a.m. You can take a break and you can rejoin by 11:45 a.m. Thank you, participants. Thank you for your kind patience.